Hello everyone, I'm Sandhya Christie, Assistant Professor ECE, and today's topic is sensors and activators. Sensor. What is a sensor? A sensor is a device that detects the change in the environment and responds to some output on the other system. A sensor converts a physical phenomenon into a measurable analog voltage or sometimes into a digital signal converted into human readable display or transmitted for reading or further processing. For instance, thermometers take a body temperatures in the form of physical characteristics, convert the temperatures into electrical signals, and convey them to their systems. Tilt sensors, temperature sensors, accelerometers, ultrasonic sensors, etc. are a few types of sensors. Here, an environment through a sensor gives the input conditioning unit of the system. Let's see about sensor classifications. Sensors based on the power requirement. Sensor is classified into two types, active sensor and the second one is passive sensor. Active sensor. Active sensors provide their own source of energy to illuminate the objects they observe. Few examples of active sensors are thermocouple, photodiode, and piezoelectric sensor. Passive sensors. Passive sensors detect energy emitted or reflected from the environment. Few examples of passive sensors are strain gauge. Some sensors based on output sensors are classified into two types. They are analog sensors and digital sensors. Let's see about analog sensor. An analog sensor is a type of sensor that measures a physical quantity or phenomenon and provides an output signal that is directly proportional to the quantity being measured. Few examples of analog sensors are: in general, analog sensors come in various shapes and sizes. Practical examples include accelerometers, pressure sensors, light sensors, sound sensors, temperature sensors, and so on. The external factors: wind speed, solar radiation, light intensity, etc. Digital sensors. At its core, a digital sensor is a device that measures a physical quantity such as temperature, pressure, light, or humidity, and then quantizes the measurement into a digital form. Digital signal only produces discrete, that is non-continuous values which may be output as a signal bit, serial transmission, or by combing the bits to produce a signal byte output, that is parallel transmission. Examples of digital sensors are accelerometers, pressure sensors, light sensors, sound sensors, temperature sensors, etc. Digital sensors produce discrete values, that is zeros and ones. Discrete values often called digital, that is binary signals in digital communication. Examples: digital accelerometers, digital temperature sensors, digital humidity sensor, etc. The next type of sensor classification is based on type of data measured. Sensor is classified into two types. The first one is scalar sensor and the second one is vector sensor. Scalar sensors. What is a scalar sensor? The sensor which produces output signal or voltage which is proportional to the magnitude of quantity to be measured is known as scalar sensor. Few examples of scalar sensors are temperature, gas, strain, color, and smoke sensor. For example, the sensor of a room can be measured using a thermometer or thermocouple, which responds to temperature changes irrespective of the orientation of the sensor or its direction. Vector sensor. What is a vector sensor in IoT? Vector sensor in IoT. Vector sensor is a sensor that detects the translation power in three directions. The sensor can miniaturize because of a simple structure and is the best for the usage of the gripping force detection. The direction of power can be detected by using the vector sensor. Few examples of vector sensor are accelerometer, magnetic field, and motion detector sensors. For example, the acceleration of a body can be measured using an accelerometer, which gives the components of acceleration of the body with respect to the x, y, z coordinate axis. Let's see about sensor characteristics. Sensors are characterized depending on the value of some of the parameters. Important characteristics of sensors and transducers are listed below. The first one is range. It is the minimum and maximum value of a physical variable that the sensor can sense or measure. For example, a resistance temperature detector RTD for the measurement of temperature has a range of minus 200 degrees Celsius to 800 degrees Celsius. The second one is span. It is the difference between the maximum and minimum values of input. In the above example, the span of RTD, that is the resistance temperature detector, is 800 to minus 200 degrees Celsius is equal to 1000 degrees Celsius. The third one is accuracy. The error in measurement is specified in terms of accuracy. It is defined as the difference between measured value and true value. It is defined in terms of percentage of full scale or percentage of reading. The fourth one is precision. It is defined as the closeness among the set of values. You can see in the given image below, the first image, the values are placed in a very closed position. So the accuracy is high and precision is also high. In the next, the values are placed in a closed position but in different places, So the accuracy is low and the precision is high. In the third image, every values are scattered here and there. So here will be low accuracy and low precision too. The next one is linearity. Linearity is the maximum deviation between the measured values of a sensor from an ideal curve. The diagram represents the sensor characteristics given above. Now let's see what is an actuator. Actuator is a device that converts energy into motion. It does this by taking an electrical signal and combining it with an energy source. In an IoT system, the actuator can act on data collected by sensors to create an outcome as determined by the chosen settings of the users. For instance, heaters, comb drives, pneumatic cylinders, hydraulic cylinders, and electric motors are some of the common actuators you can find around you. Here in the given image, output conditioning unit of a system given to the actuator to maintain and to find the condition of the environment. Now let's see about actuator classification. The first one is hydraulic actuator. A hydraulic actuator consists of a cylinder or fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion gives an output in terms of linear, rotary, or oscillatory motion. Because liquids are nearly impossible to compress, a hydraulic actuator can exert considerable force. The next one is pneumatic actuator. A pneumatic actuator are devices that convert the energy of compressed air or gas into a mechanical motion that regulates one or more final control elements. They are the devices that convert the energy of compressed air or gas into mechanical motion that regulates one or more final control systems. The next one is electric actuators. An electric actuator is a mechanical device used to convert electricity into kinetic energy in either a single linear or rotary motion. It automates damper or valve in order to increase process efficiency and complexity. The next one is thermal and magnetic actuators. Magnetic actuators use magnetic fields to generate force. Thermal actuators use the expansion of contraction of materials in response to temperature changes. The next one is mechanical actuator. A mechanical actuator functions to execute movement by converting one kind of motion, such as rotary motion, into another kind, such as linear motion. Soft actuators. A soft actuator deforms when applying pneumatic pressure where the deformation energy is generated. The present work uses a bending type's SPA to harness its bending energy based on its piezoelectric effect. Let's see about actuator characteristics. The first one is precision and repeatability. For electric linear actuators, The ability to reach the goal position as close as possible is considered accuracy, while precision represents the ability to replicate the same results relative to each other every time. Accuracy is used to measure the error between the goal position versus the achieved position. Automation. Linear actuators can be easily integrated into industrial automation systems, enabling the continuous and consistent execution of repetitive tasks without the need for constant human intervention. Time savings. A simple way to lower the speed of a linear actuator is to reduce the voltage at which you drive it. The speed of actuator is approximately proportional to voltage. This means that if you were to drive one of a 12 voltage actuator at 6 voltage, the speed would be roughly half of what it is at 12 voltage. Flexibility. Linear actuators are emerging as a new class of actuation material that can best be described as soft, flexible material that are capable of converting electrical energy to mechanical energy and thus imparting a force or motion. Space savings. For added flexibility, space saver actuators may be operated with many types of clean gases including air, natural gas, and nitrogen. Compared to more complex mechanical systems, linear actuators typically occupy less space and require a more compact infrastructure. This is beneficial in environments where space is limited. Improved safety. By automating certain hazardous or repetitive tasks, linear actuators can enhance workplace safety by reducing workers' exposure to potential risks. Now let's see few differences between a sensor and an actuator. Here a sensor converts physical characteristics into electrical signals, whereas actuators converts electrical signals into physical characteristics. It takes input from the environment. Here it takes input from the output conditioning unit of the system. It gives output to the input conditioning unit system. It gives output to the environment. Sensor generates electrical signals, activate generates heat and motion. It is placed at the input of the system, it is placed at the output port of the system. Sensor is used to measure the physical quantity, whereas actuator is used to measure the continuous and discrete process parameters, that is zeros and ones. It gives information to the system about the environment. It accepts the commands to perform a function. Examples of sensors are photovoltaic cell, which converts light energy into electrical energy. The example of actuator is stepper motor, where electrical energy drives the motor. That's it about sensors and actuators. Hope you have a clear and brief explanation regarding sensors and actuators. Thank you.